Note, Fourier transform of f of omega is Fourier f of small f omega, which is equal to minus infinite to plus infinite f of tau e power minus I omega tau d tau. Now Fourier transform of f into g, which is equal to Fourier transform of f convolution Fourier transform of g. F of Fourier transform of f convolution g, which is equal to Fourier transform of f into f of g. Inverse Fourier transform of f of tau is f inverse of f of tau, which is equal to 1 by 2 pi integral minus infinite to plus infinite f of omega e power I omega tau d omega. F inverse of f into g, which is equal to f inverse of f convolution f inverse of g. F inverse of f convolution g, which is equal to f inverse of f into f inverse of g. Integral minus infinite to plus infinite e power I omega tau by omega square plus a square d omega, which is equal to pi by a e power minus a modulus tau. Integral minus infinite to plus infinite e power I omega tau by omega square plus a square whole square d omega, which is equal to pi by 2 a cube 1 plus a mod tau into e power e minus a mod tau. Integral minus infinite to plus infinite sin square a omega omega square d omega, which is equal to a pi. So these are all the results we are going to use in the upcoming problems. So first problem, a linear transform time invariant system, a linear time invariant system as an impulse response h of t, which is equal to e power minus beta t u of t. Find the output autocorrelation r yy of tau corresponding to an input x of t. So we'll see given h of t, which is equal to e power minus beta t u of t. So we know that u of t unit function, which is equal to 1, t greater than or equal to 0, 0, t less than 0. So h of t, which is equal to e power minus I beta u of t is equal to 1, right? T greater than or equal to 0, 0, t is less than 0, right? Equation number 1. We know that h of omega, capital H of omega, which is equal to Fourier transform of impulse response, that is h of t, which is equal to integral minus infinite to plus infinite h of t e power minus I omega t dt. So we are splitting the integral negative part and positive part. So negative part minus infinite to 0. In that h of t value is 0 because t less than 0, h of t is equal to 0, equation number 1. Plus integral 0 to infinite t greater than or equal to 0 in the positive e power minus beta t into e power I omega t dt. So that is equal to integral 0 to infinite e power minus common t common, take it outside, so inside b plus I omega dt. So integrating e power ax minus ax, which is equal to e power minus ax by minus a. Instead of a you are having beta plus I omega here, instead of x you are having t here, e power minus b plus I omega t by minus beta plus I omega, lower limit 0, upper limit infinite. Whenever you are putting upper limit infinite, e power minus infinite 0, so 0 first term, second term e power minus 0, that is 1 divided by minus beta plus I omega, minus into minus plus, you will get 1 by beta plus I omega, right? This is h of omega, right? So now we are multiplying with the conjugate so beta plus I omega conjugate is beta minus I omega. So multiplying numerator and denominator by its conjugate, you will get beta minus I omega. In the denominator, a plus b into a minus b. We are using that formula, a square minus b square. Here a square is nothing but beta square minus b square is nothing but I omega square. I square you will get minus, so minus into minus plus, so beta square plus omega square. So h omega is nothing but beta minus I omega, beta square plus omega square, equation number 2. We know h star is the conjugate of h omega, so h star omega, which is equal to conjugate of beta minus I omega by beta square plus omega square. So we are changing the sign because conjugate. So beta plus I omega, changing the imaginary part sign, right? Beta square plus omega square, that is equation number 3. We know that modulus h omega square, which is equal to h omega into h star omega, right? So multiplying both from equation number 2 and 3, so beta minus I omega by beta square plus omega square plus beta plus I omega by beta square plus omega square. So you will get beta square plus omega square. In denominator, beta square plus omega square, the whole square. In the numerator, you are having beta plus I omega, beta minus I omega. Again, we are using a square minus b square formula. So b square plus minus, b square minus I omega square. So I square minus 1 minus into minus plus. So that is why beta square plus omega square in denominator, numerator. So h omega square is equal to, there are beta square plus omega square whole square in the denominator. So cancelling 1 out of them. So you will get 1 by beta square plus omega square. That is equation number 4. We know that the power spectrum of output is given by SYY of omega, which is equal to modulus h omega square into SXX of omega. So that is equal to, we know modulus h omega square from the equation number 4, 1 by beta square plus omega square into SXX of omega. We know that Fourier transform of autocorrelation is nothing but power spectrum, right? Therefore, Fourier transform of RYY of tau, because SYY of omega is nothing but Fourier transform of RYY of tau, which is equal to 1 by beta square plus omega square. So SXX of omega is nothing but Fourier transform of RXX of tau, right? Taking inverse Fourier transform on both sides, so F inverse of F, so it will cancel, you will get RYY of tau, which is equal to F inverse of 1 by beta square plus omega square into F RXX tau. So that is equal to F inverse of 1 by beta square omega square. There are two terms in right hand side. So you will get first term 1 by beta square plus omega square into second term Fourier transform of F of RXX of tau. So we are taking F inverse for both of that terms. So you will get F inverse of 1 by beta square plus omega square. So it will become dot multiplication become convolution star F inverse of F RXX of tau, right? So F inverse of F again RYY of tau, which is equal to F inverse of 1 by beta square plus omega square convolution F inverse of F will cancel RXX of tau. So that is equal to 1 by 2 pi integral minus infinite to plus infinite 1 by beta square plus omega square e power I omega tau d omega. So we are applying inverse Fourier transform to 1 by beta square plus omega square, right? So that is equal to 1 by 2 pi. So pi by beta e power minus beta modulus tau from the result formula, right? So integral minus infinite to plus infinite e power I omega t divided by omega square pi a plus a square d omega is equal to pi by a e power minus a modulus tau. Here a is nothing but beta. So we are using that formula, convolution RXX of tau. So 1 by 2 beta pi cancel e power minus beta modulus tau star RXX of tau convolution. So RYY of tau which is equal to 1 by 2 beta integral minus infinite to plus infinite e power minus beta modulus u RXX of t minus u du. We are using the convolution formula f star g, which is equal to minus infinite to plus infinite integral value f of u g of tau minus u du, right? That's it. So that is the autocorrelation of y, right? Thanks. We'll see you in the next video.